Hi children, hello, welcome back to that is your channel Physics by Imagination. Dear children, I am going to start second PUC to first PUC. Okay, so in this class, that is once again welcome back to crash course on CET. Okay, so in this class we are going to understand about that is chapter electric charges and fields. So first let us understand that introduction to matter. Dear children, you know that matter is made up of molecules. Molecules are made up of atoms. Atoms are made up of pen. That is protons, electrons, neutrons. Now the mass of the proton is about 1.672 into 10 to the power of minus 27 kg, and mass of the neutron is 1.674 into 10 to the power of minus 27 kg, and here the largest particles are neutrons and smallest particles are electrons. That is equal to 9.1 into 10 to the power of minus 31 kg. Dear children, here the strongest particles are neutrons, okay, and electric current will be conducted by on account of electrons. Okay, so this is all about brief introduction about matter. So now here atom has further split into 400 particles, and we have successfully named 26 particles like bosons, mesons, kaons, etc, etc. So this is about introduction part. Next the word will come electric charge. So what is electric charge? This is a small tiny particles which are present in the atom are called electric charges. So I mean, it is a simple definition, means they are also part of the matter. So they are nothing but intrinsic property of the matter which shows different effect, mechanical effect, electrical effect, mechanical, and etc, 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 etc. That is called definition of charges. And unit of charge is called Coulomb. So what is Coulomb, children? So Coulomb is very simple. That is, when I take two charges and that I kept in the vacuum, and there is experiences a force between them, that is 9 into 10 to the power of 9 Newton. 9 into 10 to the power of 9 Newton. I mean, a charge repulses or attracts with another identical charge. Identical charge means repulsive, different charge means attractive. That force is equal to 9 into 10 to the power of 9 Newton, and that distance 1 meter in the vacuum, that is called 1 Coulomb. And in 1 Coulomb, which contains 6.25 into 10 to the power of 18 electrons are present. Okay, this is about electric charge and unit of electric charge. Now understand about properties of electric charges. This is the code, children, easy to remember. Factseq. So what is the meaning of factseq? Very simple, let us understand now. Factseq means the first one is called fundamental property. Like charges repulsive, unlike charges attractive in nature. Second point, additivity. Suppose in this system 6 Coulomb, 5 Coulomb, minus 2 Coulomb is there. Means the total charge in the system is algebraic sum of all the charges which are present in the system. So that is total charge is equal to 6c plus 5c minus 2c. It becomes what, children? That becomes 6 plus 5, 11, 11 minus 2, that is equal to 9 Coulomb. So this is all about, that is 9 Coulomb. So please note down, children, this is property of additivity. We discussed two properties. One is fundamental property and second one is additivity property. So additivity means just adding. So come to the third point, that is C, conservation of charge. Dear children, charge is conserved. The total charges in the system, that is the number of negatively charged particles are equal to number of positively charged particles. It means number of protons are equal to number of electrons. Now, yes, always children, S means surface. Always the electrons are residing at the surface of the atom and which constitute electric current. E means about electric charge. Dear children, if the charge is at rest position, it is going to have electric field. Means, what is electric field? The region surrounded by the charge, that is called electric field, and experiences a force. Like charges repulsive, unlike charges attractive. Next, to come to the point, if this charge is at motion, dear children, it is going to produce a magnetic field. What will produce? Magnetic field. If I supply more amount of energy, that is going to produce what, children? Electromagnetic radiation. That is, when it is at acceleration, it is going to produce electromagnetic energy. Please note down points, children. So now after this, we come to the last but not least, Q. That is quantization of charge. So what is the meaning of quantization? Q is equal to N into E. It means, suppose if I remove an electron from the atom, then total charge is equal to 1 into E. What is E? Electronic charge. And that is equal to what, children? 1.6 into 10 to the power of minus 19 Coulomb. Okay. Then if I remove two charges, 2 into that. So by using this 2 times of E. So if I go for number of electrons, N number of electrons, the total charge in the atom which becomes N into E. Means this any charge you take, that should be integral multiple of E, that is equal to 1.6 into 10 to the power of minus 19 Coulomb. And here N is equal to 1, 2, 3. We feel that it is continuous, but actually it is not continuous in nature. It is not continuous in nature. That is because 1 to 2 we can find some decimal points. Hence it is discrete in nature. Okay. Now according to quark model, also we found that charge is decimal also we can get, like up, down, charm particles. You are going to study in higher studies. Okay, that is according to quark model. So please note down, that is Q is equal to, please write down, children, where total Q, capital Q is called total charge, N is called number of electrons, E is called electric charge. So later on we come to the point, that is Coulombs law. So what is Coulombs law? Let us understand very soon. Dear children, when I take a like charges and when I take a unlike charges, you know what kind of force will be there. If I take like charges, there is a presence of what force, children? There is a presence of, that is repulsive. Let us consider two charges. I am going to take identical charges and separated by small distance. There will be a repulsive force, children. Very easy. If I take a positive and negative, then there is a force of attraction. So I mean the force of attraction between the two charges, which is given by, that is Coulombs. Hence the name it is called Coulombs law of electrostatics. Means the charges will be at rest position. And we are going to find that is how electric force will be acting. So now children, this force is directly proportional to Q1, Q2. It is very similar to Newton's law of gravitation. Okay. Now inversely proportional to R square. If the magnitude of charges are more, means the force of attraction or it may be force of repulsion will be more. And if I add equation and inversely proportional to R, if distance will decrease, the electrostatic force between the charged particles will be increased. If distance increases, the electrostatic force between the charged particles will be decreased. That's it, vice versa. If I add, I am going to get, that is Q1, Q2 divided by R square. If I remove the proportionality term, I will get F is equal to K into Q1, Q2 by R square. Okay, so K is equal to 1 by 4 pi epsilon naught, and epsilon naught is equal to 8.85 into 10 to the power of minus 12, that is, so it becomes Coulomb square by Newton meter square. If I substitute, I am going to get this K as 9 into 10 to the power of 9 Newton. Very useful, children. That is going to solve in the numericals. Please note down for 1 minute. So after that, I hope you noted down. So later on, let us understand that. So Coulomb's law in vector form. Dear children, we know that what is unit vector. According to, that is, we know that according to vector algebra, what is unit vector? So unit vector means what, children? That is very simple. Vector by its magnitude. That is given by symbol. Suppose r is equal to r by its magnitude. This is called unit vector. So in vector form we can represent as f is equal to k into q1 q2 divided by r square into this. This is the vector form of Coulomb's law, and this is called unit vector. Dear children, this law I had failed to explain electrostatic force between the moving charges. Okay, it is applicable for only point charges. That is the greatest drawback of this Coulomb's law. And second one is, if distance is more than 10 to the power of minus 15 meter, this law is not going to be applicable. Okay, and here if it is greater than this means fails. Minus 20, that is minus 15 meter means it applicable. And very important, this electrostatic force or Coulombic force is equal to 10 to the power of 38 times of gravitational force. Please write down, that is Fc is 10 to the power of 38 times of Fg. So this is all about Coulomb's law. Now dielectric constant. It's very easy, children. Please note down that points for 1 minute. Please, you should write, children, because reading 10 times is equal to 1 times writing. So now we'll understand that dielectric constant. Dear children, I am going to take two charges in two different fields. So that is, I'll take, that is Fa or Fc is equal to K into Q1 Q2 by R square, means the force of attraction between the two charged particles when they are kept in the vacuum or in the air. And again I am going to keep in any medium, solid medium or liquid medium. K is equal to Q1 Q2 by R square. If I take ratio, that is going to give dielectric constant, or we can tell that relative permeability. That is equal to, that is Fa divided by Fm. This is epsilon naught divided by epsilon. So this is the formula for relative permeability. Means this is force of attraction between which kept in the vacuum. Please note down about this. And here in the numericals we should use about dielectric constant values. So I made omega square vac. Remember, omega square vac. That is, first W stands for water vapor. That is 1.007. Second one, W stands for water. That is equal to 78. Here it is a dimensionless unit, because force unit. Newton will cancel by each other. I mean Newton by Newton, it will be cancelled each other. So it is dimensionless physical quantity. Dimensionless physical quantity. V means vacuum, that is equal to 1. Air means again 1.005. Conductors means dielectric constant for metals is infinity. Remember these values. I am telling once again. Water vapor 1.007. Water, that is equal to 78, and vacuum is equal to 1. Air is equal to 1.005. Again conductors, metals is equal to infinity. So next let us discuss about electric field. Dear children, already I have told you what is electric field means. The region surrounded by the electric charges. and that is going to experience a forces that is called electric field. Okay, so now electric field strength, the force per unit charge, means how much force it is going to experience by the unit charge, a single charge, that is called electric field strength. Okay, and it will be Newton per Coulomb. So we discussed electric field and electric field strength. Come to the last point, electric field lines. The children, what are electric field lines? Very simple. So what is electric field? The region surrounded by the electric charge and experiences a force, that is called electric field. Suppose the charges are moving, then what is going to happen? If charges are moving means surrounding that there is a force of attraction or it is a repulsion. Means the imaginary lines which move along the direction of the unit positive charge, they are called electric field lines. Okay, I am repeating once again, children. That is, electric field lines are nothing but these are the imaginary lines which are along with the moving charges. That is called electric field lines, and it may be force of attraction or repulsion. So now let us understand properties of electric field lines. So the first property, if I take positive charge electric field lines, they are always moving outwards. If it is negative charge, they are moving towards inwards. And between this third property, like electric field lines, this is like or unlike? Unlike charges are there. For unlike electric field lines, there will be a attractive force. If I make it positive means again there will be a repulsive force. And one more important thing, children, that is they are always tangent to the charges. Means this electric field is always tangent to the charges. And next property we can tell that very easily, they do not intersect. They are closed loops, they never and ever intersect. Okay, because if they intersect at the same point, we will see the same point positive and negative. That is highly impossible. So this is all about today's class topics. Remaining topics we will discuss in the next class. I will make part 2 video. Dear children, please, if you like, please share and subscribe. Thank you for listening.